All right, more practice and review. Here we go. Let's get right to it. So true or false? If y equals x over e, then dy dx is 1 over e. Pause the video, answer that question. Unpause when you are ready to verify that you are correct, because you know you got this. All right, so of course you said it's true, but let's talk about why you said it's true. And you said that because x over e is the same as 1 over e times x, and 1 over e is a constant. So it's just like if I have g of x equals 2x, then g prime of x is 2. So if y equals x over e, that's the same as 1 over e times x, so the derivative is just 1 over e. Nice. Moving on. What is the slope of the curve y equals x to the fourth minus 3x squared plus 3 at negative 1, 1? Pause the video, find that, unpause when you are ready to check your work. Alright, so we should end up with y prime equals 4x cubed minus 6x. That's our derivative, so then we plug in negative 1 to find the slope at this point, and we end up with 2. Nice. We also could have used a calculator for this. This one is pretty simple with the derivative though, so calculator is probably not necessary. Moving on, draw an approximate graph of the derivative of the function. So this is the function, draw a graph of the derivative. Pause the video, unpause when you are ready to see how correct you are. Alright, so we should get something like this. So this would be the derivative. How do I get that? Well, the key thing we want to look at is wherever the function has a relative minimum or a relative maximum, the derivative has to have a 0, because that's the slope of the tangent line. Here the function is decreasing, so the derivative is negative. Here the function is increasing, so the derivative is positive. Here the function is decreasing, so the derivative is negative. So this should be the general shape, including those zeros, of your derivative. Next, draw an approximate graph of the derivative of this function. Pause the video, unpause when you're ready to look. Alright, so here we should end up with something like this. Again, the main thing you want to focus on is the relative maximums and minimums of the function lead to zeros of the derivative, and then think, okay, the function was decreasing, so the derivative is negative. Function is increasing, so the derivative is positive. Function is decreasing, so the derivative is negative, and then the function is increasing, so the derivative is positive. Now again, I don't know how high this goes. I don't know anything else really except for the general shape. Another thing to keep in mind, and hopefully you've noticed this at this point, and think about, how do we find derivatives? Well, we find it using many of our rules, but one of those rules is the general power rule. And what does the general power rule do? It brings down the power by 1. So if I think about graphs, this graph here, you know, think about our rules of polynomials. So this is a polynomial. It has 3 terms, so it means it's at least a 4th degree polynomial. So if I assume it is a 4th degree polynomial, then the derivative should be a cubic. And that's what this looks like. You know, go back here. This one had 2 terms, so at a minimum it's a 3rd degree polynomial, so the derivative should be at minimum a quadratic. Right? So when you're finding the derivative, and the opposite is true also, if you're given the derivative and finding a function, understand if that graph that you're trying to draw looks like a polynomial, then you can think about the power rule and what should your result look like. Next, find an equation of a line that is tangent to the graph of f and parallel to the given line. So we've done problems like these, but we haven't done them in a while. So pause the video, unpause when you're ready to check your work. Here we should end up with y minus 5 equals 4 times the quantity x minus 2. How do we do that? Well, first find the derivative of the function. I get 2x, but then I know that I want this tangent line to be parallel to this line. What does that mean? It means that it has the same slope. What does the derivative represent? It represents the slope. So I set 2x equal to 4 so that I can find where does this function have a tangent line with a slope of 4. And I get an x value of 2. Then I can plug that back into the original function so that I can find the y value. So remember, this line here, the only thing we're using that for is its slope. So I get a y value of 5, so then I write my answer in point slope form. Next, I want you to think about this table below. So the table shows some values of the derivative of an unknown function f. Complete the table by finding, if possible, the derivative of each transformation of f. So these are the transformations of f. So I want you to go ahead and fill out that table. Pause the video, unpause when you're ready to check. If you're confused, you can think about this one similar to some of those graphing problems we did earlier, where we were using graph information to find information about derivatives. That's one way to think about it. Also, think about general transformations, though. Alright, pause the video. Alright, so we should be able to find all of the information for g prime of x, all of the information for h prime of x. We can find r prime of -1 and 0, and we can find s prime of -2, -1, 0, and 1. How do we come up with that? Well, if g of x is f of x minus 2, then the derivatives are the same, because what's the derivative of constant? It's 0. So I know g prime of x equals f prime of x, therefore the derivative values are all the same. H of x is 2 times f of x. So therefore, h prime of x is 2 times f prime of x, because this is a constant. So again, I can just now multiply all the values by 2, and I can find all the values for h prime of x. R of x is f of -3x. So here I have to do the chain rule. So r prime of x is f prime of -3x times -3. So if I plug in, for instance, -2, then this becomes f prime of 6. But I don't know f prime of 6, so I can't do that. If I plug in -1, then this becomes f prime of 3, and I know f prime of 3 is -4, and then times -3, so that's how I get 12. If I plug in 0, then I get f prime of 0, and I know f prime of 0 is -1/3, and then I can multiply that by the -3, and that's how I get 1. But if I plug in any of these others, I'm not going to be able to, because I don't know the f prime value of that. Similar for s prime of x. So s prime of x is f prime of x plus 2, and then times 1 because I'm doing the chain rule again, but that part's not going to matter. So really, I just want to understand this is a horizontal shift, right? So in this case, the derivatives are just a horizontal shift, so I'm not going to be able to find the 2 and the 3 because I shifted everything to the left. And I can see that, you know, if I plug in s prime of -2, that's actually saying what is f prime of 0. S prime of -1 is actually saying what is f prime of 1. S prime of 2 is actually saying what is f prime of 4, and so on. But if I was to try to plug in, and so I can see, well, I don't know f prime of 4, and same if I tried s prime of 3, well, if I plug in 3, that'd be f prime of 5, and I don't know f prime of 5, so I can't answer those. But again, that's how we want to understand this. It's just, I don't know what f of x is, but I know the derivative is f prime of x. I know the derivative of f of x minus 2 is just f prime of x. I know the derivative of 2 times f of x is just 2 times f prime of x. That's it. This right here, that's just our constant rule that we learned at the very beginning. If we have a constant times a function, you can just leave the constant in front and take the derivative of the function. Alright, quiz coming up soon.